Good day, everyone, and welcome to Life Safety, Evolving Code, and Compliance Solution, a webinar sponsored and presented by CEMCO. My name is Tan Nguyen, AWCI's Education Program Manager. Before we start, a few housekeeping items. Attendees should be on mute throughout the whole presentation. Should you have a question at any time during today's broadcast, please submit it using the question box in your GoToWebinar dashboard. There'll be a short Q&A session at the end of the presentation. Handouts and slide deck are available for download in the Handout tab. At this time, I'd like to introduce our presenter, David Missler. David assists in marketing, sales, and technical support of CEMCO's FireStop offering. Previously, his career included leading a FireStop contracting business with a leading manufacturer. He contributed to the development of several FireStop products and test standards that remain in use today. Welcome, David.
Well, thank you. I appreciate it. And good afternoon, everyone. I appreciate your attendance, and hopefully we can share some information for you today that either refreshes things you have been exposed to in the past or expose you to something that you were unaware of going and have use for it going forward. So with that, again, thank you for the introduction. I appreciate that, and certainly welcome questions, whether they be throughout the presentation or at the end. We'll have time for that as well. My presentation style, I don't plan on sitting here reading slides to everyone that's in attendance, so if I skip over something and need to cover something a little bit deeper and more thorough, please feel free again as well to bring that to the conversation, and we'll do so. So with that, I'll kind of kick things off. Again, we're talking primarily about the exterior curtain wall and where an interior vertical fire barrier intersects with that. And the history of this is really started to evolve over the last few years. So this picture here just intended to give you a little bit of an overview to orientate our minds on where we're carrying our conversation today. So it's extension of that fire barrier to the inside of the exterior glass curtain wall. In the image that you can see here on the right, this is more of a partition, maybe between two rooms in a hotel or in a condominium project, but quite honestly, one of the better photos I could find of the application. So a partition may or may not be involved, really comes down to the local jurisdiction and how they interpret and apply the code language and the solutions that we're going to cover. But the intent, hopefully from the image you can see, is where these interior fire barriers, primarily like a stairwell or elevator shaft assembly or exit corridor, intersects with this exterior wall. And again, I mentioned glass curtain wall, but it could well be here like we see in the image, where we've got metal stud assemblies, whether they be sitting on the slab or potentially bypassing the slab, but the extension of that rating of the interior fire barrier to the exterior facade. So with that, we're going to focus a little bit on what's been going on in the past, talk a little bit about the present, and kind of what's happening as far as the future relates to this particular application, both from a code development as well as a product and solution perspective in the industry as well. So a little bit about the past, UL 2079. So you can see some dates here. That's been published in '94. ASTME 1966 is also in essence the same test standard. If I, as a manufacturer, go to Underwriters Laboratories and I test the fire resistive joint application between two rated assemblies, I would utilize UL 2079. If I went to an other third-party testing lab, so maybe Intertech as an example, we would be using the E1966 standard. So based on the code, it recognizes both standards. They're basically one and the same, subtle differences, but we won't touch on those here today, but very subtle differences between the two, and hence the code actually does recognize both. So the key point there a moment ago I made is that these two standards correlate to the joint or the gap between two fire-rated assemblies. And I emphasize that because we'll expand on the differences in what's transpiring in development of standards and even the current code language as it relates to these fire barriers to an exterior facade, such as a glass curtain wall, which is a rated interior wall assembly to the exterior non-fire rated assembly. So again, we'll talk a little bit more about that here in the next few slides. So Tal, if you could, let's jump into the first poll question. It's a little bit related to some additional language that's in the code as it pertains to FireStop in general.
All right, David, so 81% says true and 19% says false.
Excellent, very good. Well, I appreciate those that recognize the importance of the new language in Chapter 17, and it is true. The Section 17 now speaks to the requirements as it relates to the inspection of fire stop systems installed on the job site. And it depends on the jurisdiction. There's still a lot of jurisdictions that utilize the building department or the authority having jurisdiction, their department in the inspection process. However, if there are jurisdictions in your area that have adopted this section of the IBC code, basically what they have adopted in essence is the use of an ASTM E2174 standard and then also E2393. And these two standards speak to the methods of doing inspection or performing inspection of installed fire stops, whether they be penetrations on E2174 or joint applications for 2393. And it really applies to the different categories you can see here: high rise, category 3, category 4, and then as of 2018, the residential or group R occupancies that have greater occupant levels of 250, this particular section of the code also applies. So if you spend some time and you get into the height and table charts for the building code, if you look at the types of structures in high rise category 3 and 4 in particular, from my contracting experience, I would say that covered about 95 to 98% of the projects that are built in what we categorize the commercial environment, I should say, excuse me, something that's concrete and steel in some form or fashion. So it is a very, very wide applied requirement as the standards are written and as the code has adopted it. So when this particular section of the code is adopted, a few of the key points here. First and foremost, the owner is supposed to be contracting the company that is performing the inspection. And those inspectors, both the company and the individuals performing the inspection, have to be approved by the AHJ or authority having jurisdiction. And probably one of the biggest changes that we see as this particular standard was adopted, or these two standards, is the methods and means by which the inspection is conducted. Really, there's two different ways that they can be performed. The first is the inspector would witness 10% of all penetrations by system that are being installed, or 5% of the linear foot of joints. So in this particular scenario, there's historically an inspector that resides and works on the job site day to day while the fire stop systems are being installed, because they actually have to witness it. The other option, and again, back to my contracting days, the one that we experienced as the most frequent used was post-installation or destructive testing or inspection. And under that particular method, they would inspect 2% of all penetrations by each individual system, or one sample for every 500 linear foot of the various different systems used in joints. And I mentioned the word systems a few times. And what I mean by that is when we talk about fire stop systems, you would have a head of wall system. So maybe like the top of a gypsum wall to the underside of a concrete deck. That would be one system. Another could be a vertical joint where that wall intersects a column or maybe a CMU or masonry wall. Another application would be bottom of wall. Another would be in the mechanical joint arena where you have floor to floor type joints. So there's 4 different systems alone right there that would all have to be either witnessed based on the 5% of each joint system, or the 2% destructive testing. So basically, you can see it can become quite extensive and quite widespread, the exposure of the amount of inspections that would have to take place. So then as we go forward a little bit further in the past, but more close to today's time frame, we started to have some adoption in the code where we started to deal with what we call the slab edge or perimeter fire containment joint. And ASTM E2307 is still currently recognized in the building code. It was first published in 2004 and then appeared in the IBC in 2006. And in this particular section, that really started to speak to how we need to be able to protect that gap or that joint that occurs between the edge of slab and, again, as an example, the glass curtain wall that is protruding or bypasses the edge of slab. One of the notes here, I have that the 2307 never addressed the interior spread of fire at the vertical joints between walls. So really 2307 is dealing with that spread of fire between the gap, as I mentioned, between the concrete and the exterior facade. And now the attention is being drawn in most recent years to not only that slab edge joint, but now these vertical joints at the fire barrier partitions that are inside of the structure. So again, 2307 being referenced for the slab edge, not for the vertical joint for fire barrier. Where that first started to appear was in 2018, and you'll find that if you go back to the 2018 code in chapter 715.4.2. So this is where this language and this vertical application at the intersection of fire barriers to the exterior facade first appeared. So let's explore that a little bit more. So back in 2018, this is the excerpt of the language out of the code. Has several different key points here. It does speak to the fire barriers, so we're only talking about these type of structures or these type of assemblies on the inside of the building as they relate to the exterior facade. It also mentions that it has to have an approved material or system, needs to be securely installed in the intersection, cannot dislodge during the test or during a fire event, and it also has to accommodate movement, the expected movement that we would have at that joint. So again, starting to sound a lot like a fire stop system in the way we would talk about penetrations or other fire resistant joints. Excuse me. So where it's kind of more from there, in 2021, the language that you see here was updated, and then most recently it moved from chapter 17 or section 715.6 and 21 over to 715.7 and 24. So other than the alignment of where the language appears, the language itself as it was modified going into the 2021 IBC is the same today. So again, similar to what we saw in 2018, but some subtle little differences, and I'll highlight those here for you in a moment. But one of the interesting things that I find about this, and if you look at a lot of sections, especially with fire stop systems as they relate to code language, there's oftentimes test standards referenced for manufacturers to utilize to determine their fire stop products to be exemplified as a system or a solution. Hence, UL 2079, as I mentioned earlier, or E1966 for fire resistive joints. So again, you notice in this language, there is no reference to a UL or ASTM standard. And that still stands today. So back in 24, there was a work group that was established, and that work group has been conducting a lot of meetings, a lot of discussion, a lot of exploration on the application, and basically we're charged with bringing to the ASTM committee a standard for review and potential balloting acceptance as a new standard. So that particular work group has continued to work in that direction. They have actually, as of earlier this year, presented, I should say in 24, late 24, presented a draft standard. And as you can notice here, the expectation is that hopefully in July of 25, it will be presented for first round of subcommittee ballots. So really the takeaway here is that there is not a standard today specific for this application. What manufacturers are doing, though, is they are testing solutions for acceptance by an AHJ, and those systems or solutions are currently, more often than not, utilizing the UL 2079 or E1966 standard. So again, that's going to change going forward once there is an adopted standard by the ASTM committee, and then eventually adopted into the IBC code. But we're looking at some time that's going to take for all that to transpire. So as we look at what was originally out there in 2018 versus what appeared in 21 and now in 24, what you see with a black underline is language in the 21-24 language that was added. And in the lower section of this slide, what you see underlined in red is language that was deleted from the original language adopted in 2018 versus the language that is available today. So really, I think the intent here was they were trying to, and this is an opinion, so take this for what it's worth, but I think the intent was with the code committees was to start to mirror language that we see in other sections, i.e. the 2024 and 21 language speaks to preventing the passage of fire through the vertical fire barrier, and then also starts to speak to the prevention of spread of fire through the interior area of the building. So again, little subtle differences, but I think really the intention remains the same, just trying to clean the language up so that it may be a little bit more applicable and a little bit more easier to understand and correlate to other like fire stop applications that we have both in standards and also in the code today. So if we could, let's go ahead and launch our poll question number 2, please.
All right, so 7% says metal stud, C, aluminum frame and glass 17%, all the above 48%, and then E, A, and C 28%.
Excellent, very good, thank you. And I kind of threw a trick question out there. I said, what are the most common types? And I'd say that that's probably leaving it open to interpretation. I would more often respond as A and C being the more common applications or most common types of exterior facades. The only reason that I didn't say D, all the above, is precast concrete. You can actually get into a lot of cases where these precast panels are actually a rated panel. So that would be the only reason that I would filter that out as quote unquote a most common type. But certainly those that answer D, all of the above, I would support you. I would say that it really comes down to a perception and really the fine line determining whether or not that exterior facade, if it's precast concrete, was a rated or non-rated exterior. So again, in the context of the question, we were looking for a non-fire resistant rated exterior where that one could potentially be rated. So again, not necessarily a wrong answer. All right, so as we take a step forward from here, just want to put out some different terms that we can use as reference. And again, this is left up for individuals' interpretation and use, but so what I was saying about these 3 particular types of facades, these being the most common, the glass curtain wall is, again, oftentimes very well known as a non-fire resistant rated exterior. Other type applications could be metal stud, whether they're sitting on slab like the center photo exemplifies, or in the upper right, those where metal stud bypass the slab edge. In the metal stud applications, you will historically see like a gypsum panel or sheathing of some kind with either a stucco or brick or other exterior facade applied over top of it. All right, so fire barrier, again, back to the code language. Really the fire barrier, if we look at section 707, is where we really start to define what these type of assemblies are and where they may be used. As I mentioned earlier on, oftentimes exit passageways, stairways, could be a potential incidental use or occupancy separation. So again, fire barriers in lieu of a fire partition is probably one of the main differences that I want to draw between the 2 types here. So I have a question here as far as corridor and demising walls. And these are, fire partitions, something along those lines. They really, I would suggest by code, are not a fire barrier, and the language and the topic we're discussing today doesn't directly apply. However, I would go back to both experience as a contractor and even interacting with various different municipalities around the country. It really comes down to how the municipality and the building official and the authority having jurisdiction might choose to apply this rule of whether or not these vertical joints at those type walls also need to be protected in the same manner. And again, I'm going to tell you based on experience, I've had it go both ways. I've seen some markets where it's been enforced or applied specific to the black and white as the code defines it, only at fire barriers. I've seen other markets where it's been interpreted and applied to even a fire partition, maybe a demising wall between sleeping units in a hotel or a separation wall between occupants in a condominium style project. I don't know if you all can still hear me, but I'm getting a notice of some difficulties with my.
You're good now.
Okay, all right, thank you. Okay, the last one here is fill. So basically, this word fill or the term fill goes back to the fact that there is no specific test standard today. So therefore, the word filled is used as a descriptor for installing the approved materials that's been accepted for the application. I apologize for the difficulties we're having. And then approved, just to that, it's accepted by the building official or the authority having jurisdiction. All right, so again, let's look a little bit more now in the present. I mentioned earlier the E1966, UL 2079, and the 2307 standards as they apply to the various applications. They still remain relevant in those applications in those areas of the code today. So as I mentioned, the work group headed up by Kevin Hyland with UL Solutions has continued to move forward with development of a draft standard. It has been presented to the EO5 committee, and hoping that we see here in early half of 2025 where it actually gets presented and has some ballots cast on how this particular standard may move forward, whether it needs to come back for some additional consideration, modifications before moving to final ballot. But again, we're seeing that this standard is being developed. It is moving forward, and I anticipate, hopefully in the next 4, maybe 5 years, we might see an opportunity for it to be actually adopted into the International Building Code. Again, that's all relevant to how it progresses through committee, what types of modifications, adjustments might be needed or requested based on some of the discussion points that come back. But again, moving forward in that direction, and we'll see that, I do feel confident in saying at some point in the near future, finalized and adopted in the International Building Code. So transitioning a little bit to what we see available out there today. For the longest time, manufacturers, and this could be various different fire stop manufacturers, could be STI, Hilti, 3M, others, CEMCO, others that are out there. Because there was very little testing done, really, I think attributed to the fact there was a question in the direction on how to go test. Really, the application was being addressed through the process of engineering judgments. Again, manufacturers now, as I mentioned a little bit ago, have started to apply the UL 2079 or the ASTM E1966 test standard and come up with listed systems. Although be it, as I said earlier, it's evolving. The test standard will change in the future. What is out there today from a tested application and solution point of view, I do feel is probably better in that there's at least data behind the applications that have been tested, but we do expect, as this other standard, as I mentioned earlier, is adopted, that all the manufacturers may very well and likely have to go back and test solutions to that standard. I expect that'll probably very, very true. So without the tested and listed systems, I mentioned the engineering judgments were used, and honestly, the code as it's written, because of the fact there is no standard utilized, we are testing a solution between 2 rated assemblies, whereas now, as again I mentioned earlier, we're dealing with a non-fire resistant rated exterior wall. So again, trying to adapt and use methods and means that we have out there, the UL and ASTM standards, which does include dynamic movement requirements for manufacturers that do prefer or want to utilize that piece of the test standard, which I think it's fair that it should be. And we know from the ASTM E2307 testing at the slab edge joint that we expect to see movement between that exterior facade and the rest of the structure of the building. So why not also expect that at this vertical joint? So for those manufacturers utilizing the ASTM or UL standards and adopting to use the dynamic movement component of it, again, they're using the best options they have available today to themselves from a test standard, and also incorporating the movement and dynamic component as well as fire. I would recommend, if you care, you could take a look at what the International Fire Stop Council guidelines are issued out there for specific to engineering judgments. The IFC is a great resource for guidelines like engineering judgments, whether it be for penetrations, fire-resistant joints, or even perimeter fire containment, along with a lot of other white papers supporting the fire stop industry and companies involved, even inspection communities involved with the application of fire stop systems and the various different manufacturers' products and solutions out there. So if you go to that website, there is a drop-down menu under resources. You'll find a lot of really, really good information there. Encourage, if you've not visited that site, to do so. So what is available out there? As I mentioned, CEMCO does have a solution. There are others. Our particular solution, what we're trying to do is utilize the traditional construction methods that we see in these fire barriers today. And what I mean by traditional is we also oftentimes see, metal stud, metal frame. We're going to see a gypsum applied to that frame, not only from a fire performance standpoint, but gypsum serves and provides tremendous sound performance. And so they're based on those reasons. As we move forward with our testing, we really tried to utilize the traditional construction method of these fire barriers. And what we're doing is we're actually utilizing a metal plate to support, or an L angle to support the gypsum, which attaches to the last stud, extends out toward the glass, and it stops short of the glass. And then in that area, we use what we call CEMCO Super Seal X Black. And we call it black, or we actually colored it black, because when you look at the application from the exterior, the black bubble bead that rests against the glass really blends in nicely. It looks very, very similar to the traditional gaskets that you would see that seat the glass in the frame of the curtain wall itself. So from an aesthetic point of view, the black color works extremely well. And then in addition to it, we've tested with dynamic movement. So we do have some movement, both inward and outward movement, and also because of the bubble gasket, it will support a little bit of shear movement. And then also we have the 1 and 2 hour rating. So where we see these fire barriers, oftentimes 2 hour, unlike the picture here, I should say the difference between this and a 2 hour, this is a 1 hour wall assembly typically shown here with a 1 layer of sheetrock on both sides. With a 2 hour, you would have 2. So one of the subtle differences with what you see in the image is that return leg on the L angle that's out toward the glass. If it's a 1 hour rated wall assembly, that angle return leg is a 1/2 inch dimension. If it is a 2 hour rated wall, that return leg is a 1 inch dimension. So again, there to support and hide the edge of the sheetrock and blend in from the exterior facade. So again, WWD 0182 was tested to the UL 2079 or ASTM E1966 standards. And again, as I've mentioned previously, we would anticipate when the new standard is finalized, adopted by ASTM, and eventually makes it into the International Building Code, these type systems would likely have to be retested to that new standard. So does that mean it would change dramatically? Having had the opportunity to work with the standard committee, I would say based on where we are at today, no, not dramatically. There's actually a lot of similarity in the language of the standard that's been presented, the draft, I should say, to UL 2079. Again, there's differences, so ultimately we would all have to retest to the new standard once adopted. All right, so a little bit about the detail. Again, what you'll find when you look at the system is it's given us a plan view of it. It gives you the depiction of the metal support angle, the Super Seal X, and again, in this particular image, you see both the 1 and 2 hour wall assemblies, whether it be 1 layer or 2 layer as well. So it was an existing system that CEMCO had, but when we did conclude the testing for this particular application, we were able to get it revised through UL to now incorporate this particular application. So you'll see there's other applications for this system when you go to the actual UL system on their website. And if you're not familiar with the UL Product IQ website, I'd recommend that as a tremendous resource as well. But if you do utilize that system or visit the CEMCO website through search of this particular system, you'll see all the various applications that can be used, which this glass curtain wall is one of those. So again, a little bit of an overview of the product. You can see from the profile here, it does incorporate an intumescent tape. That's one of the things we're starting to see. The industry over the last 5 to 7 years is really migrating toward what we at CEMCO, we call a preform fire stop device. We've seen it in the mechanical, electrical, plumbing trades over the years with cast-in-place style devices for floor penetrations. We've seen preform products being used and developed in like cable pathway devices for the data low voltage. So we're starting now to see this segment grow as it pertains to fire resistive joints, and especially in the drywall joint applications out there today. So this particular product is utilized in this application among others. It can also be used at like a vertical joint where an interior partition would intersect, say, a concrete column as an example. But the bottom line is it is preformed, so it's pre-dosed. The installers do not have to be concerned with installing wet applied sealants. The tooling aspect is now removed. So again, trying to ensure that the proper amount of fire stop is installed without having the concern or need to go through quite as much, especially when we get into the destructive testing. Historically, what we found with preformed fire stops, regardless of the technology or the application, is they do not have to be subjected to destructive testing. Typically, the inspectors can see and understand that it is a pre-dosed, pre-measured product, and just visually looking at it, maybe with some pre-con or some pre-installation mock-ups, can see the installation as well, thus also helping expedite on the inspection aspect of it from that particular point of view of a job scheduling aspect as well. All right, so again, what are some of the attributes? Well, movement, I mentioned earlier. It definitely allows for inward, outward movement of the exterior wall as it relates to the interior fire barrier. Aesthetics, with the integrated mud leg, it does cleanly install. So now you have an integrated L bead, so it actually creates a very, very nice aesthetic finish, as well as has been tested to ASTM E90, thus providing some very nice STC ratings for these applications as well. So, you know, really speak briefly to STC. I mean, we really hope there's never a fire in a structure. So over the course of the life of the building, and in this case, the life of these fire stop products, they also have to oftentimes provide other attributes. In this case, aesthetics or sound transmission coefficient. So this is, again, one of the ways that these products perform on a day-to-day basis. And when and if 5, 10, 15 years down the road there ever is a fire event, then they have to also provide the life safety fire resistance capabilities as well. So again, these type products trying to be developed to address not just the fire and fire resistant aspect, but also be able to provide solutions to the day-to-day use of these products in the built environment as design intentions might be. So if we could launch our question number 3, please.
David, we have a pretty close count here. So ASTM standards 30%, test sponsor manufacturer 33%, code 30%, and D, none of the above 7%.
All right, very good. Well, we'll surprise some people. So actually, it is the test sponsor manufacturer. Yes, the code has a little bit of language as it pertains to STC requirements. They do reference the various different standards that could be utilized by the manufacturer to determine the STC performance of products and solutions. But ultimately, it comes down to the test sponsor, the manufacturer, determining the type of wall construction and the STC ratings of those assemblies that they prefer or want to utilize in the testing of their products and solutions. So really what that leads to is when we start talking about these tests when they're run, this is a very common way of testing a wall assembly. As an example, they will build the wall and construct it in like a U411, U419, maybe with or without resilient channel. Could be 2 layers of gypsum on one side, could be 1 layer on one side with resilient channel, 1 layer on the other. So ultimately it really comes down to the test sponsor or the manufacturer that is running the test and paying for the test. But what they will do is when they're testing these wall assemblies, you'll oftentimes see the edge or the gap around the wall assembly sealed with putties, with foil tapes. Basically what we're trying to do when we're establishing the STC rating of the assembly is isolate anything and everything other than the wall construction itself. So as you look at these pictures, you'll see when they run the test that isolation's been created. So what they're actually able to determine is on the receiving side of this wall assembly, they're able to measure the amount of sound that comes through at all the different frequencies that are tracked and measured. Right? So ultimately, those items, or I should say the performance of that wall assembly, is influenced by all of these attributes: the mass, the cavity absorption, so on and so forth. Is the wall decoupled? And what we mean by that is, has there been a resilient channel used to decouple the gypsum board so that it is not directly in contact with the stud? So as you create these voids and gaps and decouple, as the common term is used, you then also improve the ability of the wall to prevent the sound from transferring through from the over to the receiving side. So ultimately, when manufacturers are actually deciding to test a fire stop product or an acoustic sealant, they will choose the wall construction that they want to utilize. So where I'm going with all of this is what it leads to is the devil's in the details. When you see a manufacturer that reports a certain STC, it is all relative to the wall construction that was utilized. And I'll give another example. If I take and put a fire stop material in a non-fire resistant rated wall assembly, just by applying a fire stop material around a penetration or in a joint, doesn't convert that non-fire resistant rated wall assembly into a rated wall assembly. So the same as it applies to sound. If I test a product with a wall that has an STC of, say, 52, I'm not going to be able to outperform just by simply putting that fire stop or acoustic product in the wall and elevate that wall to a 57. And in return, if I test with the 54, if I use the product in a wall with 57, it would be expected that the result would demonstrate that the product would perform equal to the wall. So if we look at a sound report where a manufacturer is tested with, say, a 50 or a 52, it's very well oftentimes understood if that product is used in a wall with a 57, it would perform equally. So basically what we need to see in the test reports for sound is that the product restored the sound rating of the wall by use of those materials in their respective application. Again, similar to what we would expect from a fire point of view as an example. Alrighty. So what we see out there is different manufacturers and the way they test. We've seen testing that's been reported with STCs up to 60, and we will see that in the detail of some of those reports, oftentimes 3-4 layers of gypsum board used to achieve these types of ratings. So again, as I mentioned a moment ago, the devil's in the details. So really would encourage users for selecting fire stop or acoustic products for use in these applications and even penetrations to get with the manufacturer of choice and really understand how they achieved their individual STC performance, because it really comes down to, does the data support the construction techniques on the project that the materials are going to be used in? I've seen examples like this where on the receiving side they had 3 layers of board. I'm not saying I never see walls constructed with 3 layers out there, but honestly, rarely we don't. You know, it's a common wall construction, 3 5/8 metal stud, a layer of sheetrock on each side, maybe a single layer on one side and a resilient channel to achieve the other. So again, it's all about the constructability, the related cost, and achieving the performance based on what's being utilized as a wall assembly in the project, and ensuring that these particular projects or the products that are being used support the application that is desired. I should say the result that is desired. So here's an example of some typical walls. You know, a baseline wall, as I mentioned a moment ago, oftentimes a layer of sheetrock on each side, maybe an R13 or a 3.5 inch layer of glass fiber installation inside of it, and we'd see that wall tested with an STC of a 45. This is a typical wall that we utilize because it is a common wall found in construction today. We could go test walls with 3 layers of gypsum on one side and actually make our products look like they perform potentially better than what they do. But again, what we're trying to do as a manufacturer is represent our products in applications based on what we see as typical construction in North America today. So again, just as an example of where the devil's in the details, what can be found and what you can see by asking for a complete STC report to show how the walls were built, how it was tested, and what the results of those tests were. Another example here I mentioned a minute ago, you know, you see walls where we have 2 layers of board on one side, one on the other, again, oftentimes perform at a 50 STC as well. So again, we're finding that our products will restore those ratings of the walls when our products are used in these applications in their respective locations. All right, so where does that take us in the future? Spend a few minutes there and then we'll open up for some questions. Well, basically, what we know from the way codes have been developed over the last 20 years, codes are oftentimes reactive to events that occur. I had an inspector that I was visiting with not too long ago, and his comment was that there is a life behind every code that's been developed and adopted. And when it comes to the fire-resistant aspect of our design and construction today, by the examples you can see here, unfortunately, that is probably way too common and way too true, that it does unfortunately take deaths and injury to help us understand how we can advance testing standards and advance codes. So not only from a fire point of view, but we think about, you know, recent years past where we had all of our lives changed due to COVID. You know, so set aside fire-resistant construction. Today, we see language in codes being changed as it relates to air quality, ventilation, so on and so forth, because of what we now have learned from these type of airborne diseases that we need to design buildings and structures to accommodate. So bottom line is the codes will continue to evolve. What we saw 20 years ago, there's definitely been advances and changes today, and 20 years from now, we could expect to see these type of changes again occurring. You know, again, it could be fire resistant, it could be environmental, could be a lot of different aspects of the code, but it is constantly evolving and reacting to what we actually experience in our day-to-day lives as we move forward in time. So again, we talked earlier about the ASTM committee and the work that they're doing. So we know that changes are likely going to come a few years down the road. So again, will these products that are out there today still remain code compliant? We hope so. But as I said earlier, we also expect that we're going to have to go back and we're going to have to test to these new standards as they are adopted for this specific application. So basically to be determined, but I know that manufacturers will always constantly take a look at, keep a pulse of what's happening in code development, and constantly work and strive toward developing solutions and products that meet the codes as we have them today, but also as we see the direction that they're moving in the future. So earlier I mentioned a couple of different publications. I mentioned UL Product IQ. Would also mention the ICC publications, the significant changes to the IBC. I like that document because it's kind of the cliff notes, right? I mean, if we had time, which I wish I did, to sit and read new code books as they're released and adopted from cover to cover would be great. But the changes, significant changes, is kind of the cliff notes. It does a really, really good job of summarizing the various different changes by section. And it's a great way to go back and catch up on and even hone in on areas of the code that are most important to you respectfully. Other resources out there, again, our website, you'll see information as it pertains to the fire stop, also with the steel framing, metal lath, and those type things. And just a quick note there about CEMCO. You know, we've been around for 50 plus years now. People most recognize us for our contributions in the cold form metal and track side of the industry, but we're heavily involved in the exterior facade, specifically for stucco, and then actually one of the leading companies when it pertains to preform fire stop products. I would say we've actually been a little bit ahead of our time. The industry is, to some degree, catching up with us. We've had these products out for 12, 13 years, and like I said earlier, in the last 5 to 7, we're really starting to see the industry move toward these preformed products in the joint application. So we feel it's fair to say, and we're proud to say, that we feel we're contributing to the development of this segment of the industry and the products and solutions that are available within the industry as well. So for those of you that maybe need some assistance going forward after this, please feel free to reach out. You do have my mobile number there. You also have Akira's mobile number. He's another team member on the CEMCO team. Rest assured, if we don't answer, it's because someone like yourself is giving us their time. So when we get done with those conversations, one of the first things that we do is we start to follow up on voicemails, emails, those type things. So please, if you reach out, we don't immediately answer, leave us some information. We'll be glad to respond and do so. And then we also have a great technical services team supporting us out in the field as well. We also have a new member that we've added to the team, Jaime Manzo. He'll be starting and based in our Denver market and covering the Western Seaboard for us starting here over the next month or so. So look forward to having additional resources to support your needs out there as well. So with that, I would like to open up the floor for questions or any other additional follow-up that we might have based on the conversations so far today.
All right, thank you, David. There's a couple questions coming in here. Is it recommended that project documents define joint widths and movement requirements?
A great question, and yes, I would go back to my contracting days. This was an area that we constantly tried to address by issuing an RFI within the architectural design firm for the projects, because oftentimes we would get a little bit of a mixed message. We might see a 3/4 inch joint at a non-rated partition, a 1 inch joint at a rated partition, and then even further, we might see an 1.5 inch joint like at a CMU wall application. Well, in that example, we know that those 3 wall types will intersect each other. So when you have a 3/4 inch joint at a non-rated partition intersecting either of those other 2, they actually begin to work as a bump stop. So it actually would limit the travel. So again, harmonizing the joint widths across the various wall types is a wonderful place to go. And the last point we would add to that is also potentially creating what we describe as a no-fly zone. What I mean by that is taking penetrations like sprinkler pipe and conduit and dropping them down a couple of 3 inches below that head of wall joint so that they themselves also do not impede or potentially restrict the movement at that joint as well. So again, great question, and thank you for that.
So UL system WWD0182 shows the wall terminating at 1,000,000. Would the detail be different if the wall terminated where there was no mullion?
Yes. So I think as we're describing that detail does show where it comes into the vertical mullion, where it comes into the glass, it absolutely would be a different detail, and something that we could take a look at any particular project documents that you might have and offer some potential solutions there as well. I would say that we're seeing more and more design at the architectural level where they're trying as much as they can, and I emphasize that trying. There's always outliers or different examples where they have to go to the glass, but they're trying to incorporate that vertical mullion into the application, even if they need to create steps or jogs in the wall to get over to where that vertical mullion applies.
Does WWD 0182 address movement from a drifting of the exterior wall?
Yeah, so I mentioned earlier, we used UL 2079 as other manufacturers have. So drift is not a part of that particular standard as it pertains to the vertical joint. Although because of the nature of the bubble gasket and other tests we have done with this product, like in head wall, yes, we can support some drift. And I use the word drift, and as the question asks, it's drift. It's really maybe a little bit of a sway, right? Because when we look at a high-rise building, as it moves with wind applications, the exterior glass curtain wall is sliding a little bit, if you will. So oftentimes we'll say that is drift. So yes, it will support that drift or shear movement to some degree.
Will lighter gauge studs improve STC performance of a wall?
Gauge of stud will definitely affect the performance of the STC of a wall assembly, yes. So again, go back and take a look at the different, I would suggest looking at the different wall assemblies, maybe starting with, there's several different options out there. The Gypsum Association publishes some great documents on wall construction and STC. Recently, National Gypsum published some documents on selecting wall types, both for fire resistance and also sound performance. So resources out there that are great sets of documents to utilize as reference. So would encourage you, have in mind the STC that your project needs and take a look at the different types of wall structures that are out there. But yes, definitely stud mill thicknesses and gauges definitely will contribute to that performance.
Great, thank you. And will the forthcoming test standard for the vertical fire barrier to non-rated exterior wall be to retard interior spread of fire or prevent the passage of flame?
I hate to ask, but could you say that again?
Yeah, I know it's a long one. Will the forthcoming test kind of for the vertical fire barrier for non-rated exterior wall be to retard the interior spread of fire or to prevent the passage of flame?
So it's the interior spread of fire. The language is going to be very similar to what we see in ASTME 2307. So I think the intention of the work group is to utilize common language that is currently in the code for that slab edge condition. So it will address the interior spread of fire from one side of the wall to the other.
And we're going to wrap up with one last question here. How does sustainability intersect with fire and life safety compliance?
Oh, another good question. And my short answer, I would say it really pertains to the manufacturer, right? Just as a quick answer to that, as quick as I can, all fire stop manufacturers have to go through what's categorized as a follow-up service with a third-party test lab that they have listed their products and tested their products with. So when the labs do their follow-up service, they physically take a sample of that product off of the production line today, and then they take it back and they compare it as far as a chemical fingerprint is the way I would describe it to the product that was used to obtain the listing, whether that was last year or 10 years ago. And there's a very, very narrow band or a tolerance of variation in those fingerprints between the products. So for that reason, depending on the makeup of the product, some products can contribute less or more on the lead, the recycled content aspect. It really comes down to the formulation of the product. Historically, your preformed products would potentially provide a little bit more contribution because there are components such as plastics and vinyls that don't deliver or contribute to the fire performance. The intumescent strip is what's contributing. So the intumescent strip may not have as high a value, if any, recycled content, but the other components could. So therefore, always recommend you go back to the manufacturer of choice being used on the project and ask for their updated information on the products that have been submitted and approved for the level of contribution that they can provide.
Well, thank you so much, David. That concludes our Q&A session. Thank you, CEMCO, for sponsoring this webinar. If you have more questions for David, please reach out to him. And thank you, everyone, for joining us today. We'll see you next time.
Thanks, everyone, for attending.